Alrighty, we're going to look at Chapter 2, Section 5. This is calculating best fitting lines and making predictions from that data. Before we get started, we're just going to do a simple scatter plot. It's a plot of points on a coordinate plane given specific data. In this case, we're given ordered pairs. So that first one, we got that -4, -4. So all we're going to do is we're going to plot that point, -1, 0, 2, 3, 5, 4. Okay, so there's your scatter plot. No lines, nothing. Scatter plot is just points. Now, what we're going to be doing today is we're going to be finding the equation of a line that fits this data. Now, a line is straight, okay, constant slope. So since these points are kind of off of it, we're just finding that line that best fits them. So we can get as close to that line as possible. Now, there's a few terms that we got here. Correlation coefficient. When we get to it, it will show up on your calculator. It's a measure of how closely a line fits the data. So how close that line gets to the points. Okay, R values that are positive will have a positive correlation. R values that are negative will have a negative correlation. Okay, now this value is always going to be between 0 and 1. Anything above 0.8, that's going to be a good fit. Now, once it hits that 0.9 or better or greater, it will be a very good fit or strong fit. Okay, these scatter plots must have the dimensions of your windows and labels to receive full credit. I'll show you what that means here when we actually do the scatter plots. But now, before we get going, we got to talk about correlation. Okay, correlation is just basically how those coordinates work with each other. We got X and we got Y. How do those correlate with each other? So for positive correlation, as X increases, so as we go right on a coordinate plane, what is that Y doing? If Y is increasing or going up, that is positive correlation. So X increases, Y increases. Negative, as X increases, so as we go right, those points are going down. Okay, then there's going to be some situations where there's relatively no correlation. There's no linear pattern at all. So if we look at the three graphs there, okay, the three scatter plots, okay, and the first one on the left, there's no really linear pattern by any means. So this is a case where there is no correlation. Okay, moving on to that next one. As we go right, those points are going up. So as X increases, Y is also increasing. So there we have a positive correlation. And as you can guess, the next one is negative correlation. Okay, as those points are going right, they're also moving down. So that's where X is increasing, Y is decreasing. That's why it is a negative correlation. Okay. So again, just looking at the correlation of the scatter plot, as X is increasing, Y is also increasing, so this is a positive correlation. And then as X is increasing, Y is decreasing. So as we're going right, the points are going down. This is where we have that negative correlation. All right. So now let's actually get into given us some stats. Let's find the scatter plot, and then let's actually find that regression equation or the equation of that line that best fits that data. So in this case, you have a job installing software on new laptops. The number of laptops you completed each hour of your first day are recorded below. Okay, hours of the day. That's like your X, and then the laptops completed that hour are your Y. Now, a lot of these cases, we're dealing with real life situations, so we're just going to be dealing with the positives for the most part. So all we really need to deal with is the first coordinate of a coordinate plane. So we're just going to draw that first quadrant, and that's it. Okay, now to do this, what we're going to do is we're going to use this app, Calculator Pro, which everyone should have. If not, you need to get onto Mozo and download that. Okay, so if we find it here, there it is. Okay? And this is going to be basically just like the TI-84s that you see in class. Okay, now the first thing you're going to need to do, okay, on here it's not a big deal, but when you have a TI-84 calculator in class, you're going to have to go to the catalog. You hit that, do that by hitting second 0, and then you're going to go in there. It's going to look a lot different on the calculator, but you got to turn the diagnostics on. We don't have to worry about that here. Okay, I'll show you guys that in class, and it's also on the handout that's in OneNote for your directions on linear regressions. But so since we're dealing with stats, we're going to go hit this stat button, okay, and we got to enter these stats into the calculator. So stat, and you see that it's highlighted as edit, so we're going to edit, and we're going to enter some information in here. Okay, we're going to enter the information that we were given. Okay, so we were given hours of the day. That's going to go under your list 1. Okay, and if you have data in there, all you have to do is highlight L1 and hit clear. And once you go down, it should clear. So let's clear both of those, and let's enter our data. So we had 1 through 7 for our X values. And then for our Y values, or the laptops completed that hour, we got 1, 3, 4, 3, 4, 5. Basically, we have ordered pairs here that we can plot on a coordinate plane. Now, what we're going to do is we're going to graph this scatter plot on our calculator. Now, before we do that, we need to make sure our stat plot is on, because we want those statistics to be plotted onto the graph. So in order to do that, you're going to hit second, and then if you look at the Y equals, the very top left button there, so you see plot, you got to make sure that that plot 1 is on. Now, for a lot of you, it will be off, so all you have to do is hit enter, and then make sure that it is turned on. Okay, so then we can go second quit to get out of there, and what we're going to do is hit graph. Now, right now, I did a separate scatter plot earlier. What we need to do is we need to zoom in to our specific stats. So you're going to hit zoom, and you're going to hit zoom stats. So that's that 5. So you can either go down, highlight it, and hit enter, or you could just hit 5. Now you see our statistics that are given. Okay, that's our scatter plot. So then you're going to go there, and you're just going to do a rough sketch of what that looks like on the calculator. Okay, so that first point was pretty low. Just think of it like that's 1, 1 as an ordered pair. Okay, then it was 2, 3, 3, 4, 4, 3, 5, 3, 6, 4, 7, 5. So that's what it's pretty much looked like. Okay, it's just a rough sketch. It doesn't need to be exact. Okay, but the other thing that we need here is our labels and a scale. Okay, so the way we're going to find our scale is in our window. It's that very top left button right next to Y equals window. Okay, what you're going to write in there is that X min, X max, Y min, Y max. Okay, so we got 0.6 to 7.4. Okay, and X min, X max, that goes along your X axis. Okay, and we had our Y min, Y max at 0.73. And then our Y max at 5.27. Okay. Then after that, we just need our labels. Okay, so our x-axis, that was hour of the day. Okay, and then laptops completed that hour. Okay, those are the 3 things that you need when you are doing a scatter plot. You need the actual scatter plot, so the points. Okay, you need your scale, or your X min, X max, Y min, Y max, and then your labels. Now, in order to find the regression equation, okay, we're going to have to go back to the calculator. Now we actually need to run some type of test on the statistics to get our regression equation. So we're going to actually calculate something. So if you go into that stat button again, and you're going to arrow over to calculate, and what we're going to calculate now is a linear regression. Okay, so I'm guessing you guys could have seen LIN regression, line regression, AX plus B. If you've noticed, that's just like slope-intercept form. You're going to hit enter. We entered our X values into list 1, so X list, L1, Y's into list 2, so Y list, L2, and then you're just going to hit enter until you hit calculate. And then there's our regression equation, Y equals AX plus B, and then it gives us that A value and that B value. All you're going to do is take that A value, plug it into A, B value, plug it into B. Now, we're going to round to 4 decimal places, and that's going to be consistent all year. This skill that we're doing right now is going to be something we use all year. So, we got 0.464, 643. Okay, here we go. So Y is equal to 0.4643 X, okay, plus we had 1.4286. Okay, that is your regression equation. Okay, that is that equation of that line. If we were to draw a line through this data, that would be the equation of that line. But we do not draw that line on our scatter plot because the scatter plot is just points. So make sure you are not drawing this. Okay, that equation tells us what it will be. Now, what is the correlation coefficient? Again, that's that R value that was given to us. So 0.8001. So R equals 0.8001. And then if you remember, up top, we talked about how that correlation coefficient fits the data. 0.8, that's a good fit. I mean, the dots are getting away from the line, but not too bad. This is a good representation for this line compared to the data. So we got a good, and then we also have that positive and negative correlation. You know, just looking at the scatter plot, you can tell as we go right, we go up. Okay, so as X increases, Y is also increasing, so we have good, positive correlation. Okay. Now, I'm not going to go specifically through this whole thing again. This one is a little different. It's just a matter of making sure you're reading carefully. Okay, so the table below shows the average starting salary for a beginning teacher in North Dakota for the years 1998 to 2004. Here's the important part. For the data, X represents a number of years since 1998. Okay, so a lot of people like to just go to the calculator right away and plug in 1998, 1999, 2000. We cannot do that in this case. Okay, 1998, if X is representing the number of years since 1998, it's been 0 years since that point. Okay, 1999, that's 1 year. 2, 3, 4, 5, 6. Okay, so really when you go into list 1 and plug in your X values, it's going to be 0, 1, 2, 3, 4, 5, 6. Okay, your Y values are your list 2. That's where we're going to plug it in just like normal. Okay, now I did this on a separate calculator. If you need to see the calculator steps again, rewatch the first example. But this one should look like this. Okay, got a big jump there. Okay, and then our window, we got negative 0.6, 6.6. Okay, Y-min 13,920.9, 16,909.1. Okay, and again, that's 2 of the 3 things we need. We got our scatter plot, we got our scale, now we need our labels. Okay, so X years since 1998, and then this will be starting salary. Okay. All right, so then finding that regression equation again, that's where you go into stat calculate, we're going to get y is equal to 411.4286 x plus 14,165.7143. Okay, correlation coefficient. Let's see what that was. Oh. So this is where I did not have my diagnostics on. So on your calculator, like I said, I'll show you come the time in class. And that's going to be under your catalog. And we get a correlation coefficient of 0.9679. And again, now that one's above 0.9, so that's going to be a strong. And as x was increasing, y was also increasing, so it's positive. So we got a strong positive correlation. Also, whatever that R value is, the correlation coefficient, if it's positive value, it's going to be positive. If it's negative, then you have a negative correlation. Okay, now the big thing with this one here is using that regression equation. I want us to predict something that happens in the future. So use your regression equation to predict what the starting salary would be in 2011. So now we got to figure out that x value, because x is representing the years since. Okay, 2011, that's 13 years since 1998. So all you're going to do is you're going to take that x value of 13, plug it into your regression equation. Now, a lot of people make a mistake when they plug this into the calculator. So in order to get at least half credit, I want to see that you knew that x was 13 and that you knew to plug it into that x value. So if you write this step right here, you get half your points, okay? And your other half point will come from when you plug it in, and you will end up getting 19,514.92, okay? So that is the expected starting salary for a teacher, new teacher in 2011. Okay, so there's two examples. If you have questions, this is a process you'll be using all year. Right now we're just doing linear. We're going to move on to quadratics and cubic and quartic functions. Okay, using this. Okay, I did that third one. Okay, so if you want an extra practice, try it on your calculator. See if you can get the values that I got. Now again, this is be careful when you are doing your x values. If you notice in this one, it said x represents the number of years since 1990, and look at how the values go: 1990, 1991, 1992, 1994. So don't just assume that it's going to go straight in chronological order. Okay, it could jump. So like in this case, 0, 1, 2, 4, it makes that jump. You need to be mindful of that and plug in the correct values, because a single value plugged in incorrectly could mess up the whole problem. So make sure when you're plugging this data into your calculator, you are doing it correctly. Other than that, you got a worksheet that goes along with this. Okay, this will be all in your folders, linear regression. Okay, you got some problems there. Start working on those, come to class with questions. Other than that, have a good day.